In this recording, we will talk about the electroscope, which is an instrument that allows us to get a qualitative measure of the amount of electricity or the type of charge we have. And then we'll discuss a few cases about charge distribution and what happens to charge. Now, the setup of an electroscope is just a piece of metal, conducting material, that's in the shape of a T usually. And then we have sometimes this can be made up of very thin foil, metallic foil, or it can be just something more sturdy than a foil, what we call the vane, something that can move. That's what we see here of the diagonal. And the idea here, the more charge we subject the electroscope to, the more of the vertical the vane is going to move. Okay, we have, I'm not sure why they are not showing it here, but that we go back one screen and back up, so hopefully that will get them to work. You see there we have an animation of the way the vane works. So when we approach a charge, then the vanes of the electroscope move apart. Now, notice here in this one, we approach a negative charge. What happens when we approach the negative charges in the electroscope move away from the top to the vanes, so the vanes would have a net negative charge instead of being balanced. Now, once they have a net negative charge, they move apart. The bigger is that charge, the further apart they are going to move. Here we have the opposite. We approach a positive charge. When we approach a positive charge, then the negative charges that were spread evenly to balance the positive charges within the electroscope, the negative charges are going to be attracted to the positive charge on top. And then when we do that, that will leave us with a net positive charge in the vanes. So then the vanes are going to repel each other and they move apart. Notice that in this case, in neither one of these cases, we don't touch the electroscope. We just approach the charge, either the negative or the positive. We just approach it and we see the effect of approaching it on the electroscope. Now, there is a simulation that does that I pulled up. You have the URL. So what we do here, so we have the vane, we have the conducting material, and that's the electroscope. So when we play it, that's the idea. So in this case, we have the red charges, whatever they are. Now, when we approach it, the blue ones, the opposite charges, are going to be attracted to the top. And then, okay, let's play it again. Oh, we need to reset. The red ones are going to stay as far away from the top as possible, giving a net charge to the vanes, and that's why the vanes are going to move apart. Notice here that once we have the charge far away, the electroscope is neutral, so we don't see any charge. I'm closing it to reduce the load. Okay, let's go to the next screen. Okay, how would we charge the electroscope? We can charge it through conduction, what we call conduction. What we do, we approach the charged rod near the scope, and then we touch it. We touch the top of the scope with that rod. Then what's going to happen? Some of the charges in the charged rod are going to move to the scope, leaving the scope with the same charge as the rod. That's one way of charging the electroscope. Let's see here if we can run this tiny simulation. Okay, so we approach the rod and we touch it. So since we approached positive charges, what happened in this case when we approached positive charges, we attracted negative charges and got them off the electroscope. Here we are not showing really an electroscope, but that's, okay, see it again. So then we leave the electroscope with a net positive charge. Okay, let's see the simulation here. Okay, so we touch it. Okay. The one to the left, it's neutral now. The one to the left brings negative charges, so it's going to leave some negative charges. So we are left with an excess of negative charges here. Okay, see it again. Here we had 4, now we have 2, and then we have 2 extra ones here. Now in this one here, we approach positive charges, so then we are going to steal 2 negative charges, then this is left with a net positive charge. Okay. So the whole idea is, whenever we approach a charge to a medium, if we are going to touch the medium, then we are going to have a transfer from one to the other. In this case, if I approach a negative charge, then the negative charges, positive charges are not going to move much because the molecules are not going to be able to move much. They are much heavier. They are held with strong forces to the rest of the molecules. However, the electrons can jump, and that's what we have happening. Now here, look what's happening here. When we approach the negative charges, what's going to happen is the negative charges in the molecules are going to be repelled, so they are going to be the furthest away from these negative charges as we can. And then when we put it close enough, some of these negative charges are going to make the jump. Just a note here, what do you think? This top material here, is it a conductor or an insulator? Of course, it is an insulator. Otherwise, the electrons are going to be free to move, and they are going to move away all the way to the other side instead of remaining stuck to their atoms.